Welcome back. We are now going to be talking about negative exponents, and we'll be able to rewrite them in a way to get rid of those negatives. So for negative exponents, we want to think about what could be the opposite of multiplying. If you've been in my class before, you've heard me say, well, what's the opposite of add? It would be subtract. So what's the opposite of multiply? It will be to divide. So the opposite of multiplying is dividing. So a negative exponent tells you how many times to divide a number by itself. So that's a kind of written. You're going to be dividing a number by itself. And we will do some examples here. So first example, we could have 8 to the negative first power. And what that is going to tell us is it would be the same thing as doing 1 divided by 8, which is 1/8, or 0.125, or 125 thousandths. Or you could do it, we could have it where we have to divide by the same number multiple times. So we could have, for example, 5 to the negative third power, which would be 1 divided by 5, divided by 5, divided by 5, divided by 5. There are 3 5s there. Oh, I put one too many. Let's back that up. There we go. So it's 1 divided by 5, divided by 5, divided by 5. Because there are 3, it tells us how many times to do it. And that is going to equal 0.008. But there is an easier way to do this too. So we'll do the same example. 5 to the negative third power could also be calculated like this. We could do 1 divided by 5 times 5 times 5. So we could do the multiplying first, which would be 1 divided by, remember divided by we can also use as a fraction, to the 5/3 power. And we're still going to get the same answer. .008. So it's just telling us how many times to divide by that number. We can sum this up nicely in the negative exponent rule. The negative exponent rule just tells us that to change an exponent from negative to positive, we're going to use the reciprocal. So the reciprocal, I made myself a really small line here. Is a flipped fraction. So we take our fraction, whatever it may be, and we flip it over, and that is how you find the reciprocal. So for some examples, so you can see that, the reciprocal of 1/2 is 2 over 1, which we know is also just 2. 2 divided by 1 is 2. And that's the reciprocal. We flip it. If we had the reciprocal of 3/4, that would be 4/3. To switch it from negative to positive, you flip the fraction over. That's it. You don't need to worry or think too much. Just know we flip them over. And this works from top to bottom, which means if you want to take a negative exponent on the top, and you put it to the bottom, or if there's a negative exponent on the bottom, you can take it and put it to the top to make it positive. It works in both directions. We will do examples where you can see both directions. All right? Let's just do some examples and see if it becomes a little more clear by practicing. So what if we have 8 to the negative second power? That becomes 1 over 8 squared. We flipped it. Whenever you have a whole number, it's invisible over 1. So we flip the whole thing. Now we don't want to leave it like this. We are going to want to simplify it. So we end up with 1 over 64. Because it's 1 over 8 times 8, which is 64. We'll do another example similar so we can kind of really get the hang of it here. What if we have 4 to the negative second power? That would mean we would have 1 over 4 squared, which would be 1 over 16, because 4 times 4 is 16. Now we don't just have examples where there are integers. We also have examples where there are variables. Because this is algebra, we got to throw some letters in there, make everything more fun, right? Let's try a couple like that, where we've got some variables. So if we had, for example, x to the negative fourth power, we would have 1 over x to the power of 4. We would have to leave it like that. There's nothing else we can do. We can also have examples where we have variables and we have with a coefficient, which is a number in front of the variable. An example of that would be something like 3x to the negative 2. And what would happen here is we would only take the reciprocal of that exponent there, so it would end up as 3 over x squared. We just take that x to the negative 2 and drop it down because it's negative and we want it to be positive. You see that? We didn't take the 3 down with it. We just took the x and the exponent. Just put like in a little invisible line here. We're going to do some more examples on the other side. We can also have some where only we have multiple parts and only some are going to drop to the bottom and others are going to stay on the top. So let's see. An example of that could look something like this. We could have 2x to the fourth, y to the negative eighth, and z to the negative first. That's all one thing. We are only going to take and drop the ones that have negatives. Everything else is going to stay on the top here. So what we end up with is 2x to the fourth over y to the eighth. That becomes positive now. And z to the first. When you have an exponent that's to the first, you can omit it. You can just get rid of it. So it could also be 2x to the fourth over y to the eighth, and then just z. That would work as well. That's just a little detail. So you're only switching what's negative. We haven't done an example yet where there's a negative on the bottom already, so we're going to do one of those. We could have 7x to the negative third over y to the negative fifth. So we need to switch or take the reciprocal of the negatives. So what we're going to end up with is 7, that stays on the top, y to the 5th is going to come up, and x to the 3rd is going to go down. I would pay close attention to these examples because a few of them are on your assignment. I'm not even going to pretend to be sly. I'm just going to tell you very honestly. Copy these examples down. Make sure you get them because they're going to be on your assignment. A few of them. So the negative exponent rule, we're taking the reciprocal, we're flipping. Now the last thing I want to show you is this graphic here, and I did take this from the website mathisfun.com if you're interested in looking at more and more of their examples. But we can look at this to see why this makes sense. Why we're dividing and then multiplying, how exponentials work. So for an example, if we take the powers of 5, we learned last time that anything to the power of 0 equals 1. So 1 is right here. And as we go up, 5 to the 1st is 5. 5 to the 2nd is 25, or 5 times 5. It's getting 5 times larger every time we move up. It's exponential, right? We learned about this, like, I'm sure on the news, you've seen exponential cases of COVID and things like that. It gets bigger and bigger by powers of 5. And we can also, down here, get smaller and smaller. Same way, exponential decay. We're going to learn about that later. So 5 to the negative first power is 1 divided by 5, which is 0.2. 5 to the negative second power is 1 divided by 5 divided by 5. That's 0.04, or 4/100ths. It's getting smaller, smaller, by 5 times smaller each time. Our curves roughly look like this and like this, right? The smooth curve, they go exponentially higher or exponentially lower. We're going to learn and look a lot more at growth and decay with exponents. But I just wanted to show you this little table because I think that it's a pretty good example and visual of how this is working. If you have any questions, you know where to find me. I hope that you have a great day, and I see or hear from you soon.